Okay. Yeah, my name is Rachel, and I'm writing a thesis about a centrifugal pump used for rocket engines. And this pump is designed by Eivind Liland in Orbital Machines. And he started Orbital Machines in order to design and sell these pumps to the space market. So this pump is an electric fuel pump, which are supposed to replace the more traditional gas turbine pumps. And the advantage of this pump is that it's cheaper, safer, and more flexible due to one design that can be adjusted to different kinds of engines. And the only changing parameters is the pressure, the flow rate, and the fuel density. And since I didn't design the pump myself, I made a 3D print of the pump in order to understand how the components were put together. And it was actually very helpful to understand the design, since I didn't do it myself. So, the objective of my thesis is basically to design a test rig to verify the design before it's tested in the engine of a rocket. And it's decided to conduct measurements in the lab. And this is to find the efficiency of the pump, which is the hydraulic power divided by the mechanical power. And to do this, we have to measure the differential pressure between the inlet and the outlet of the pump times the flow rate. And the mechanical power will be the torque of the engine shaft and the angular velocity of the rotation. And also it's decided to look at the pump curve diagram, which look at the relation between the head and the flow rate. And this is to look at the behavioral of the pump at different operating points. So you can see the impact of the different kinds of losses, and also you can find a best operational point for the pump. Yeah. So what I've been doing this fall is to basically design the rig. And this is the initial design based at the Water Power Laboratory. It consists of an engine, a torque meter where the torque and velocity, the angular velocity, will be measured, and the engine shaft. And added to this rig is a driving belt system consisting of 2 pulleys and 1 belt. So the big pulley drives around and drives around the small pulley where the pump is supposed to be connected, like this. So you can see the pump is a bit small in this drawing, but yeah. So you can see the inlet pipe and outlet pipe, and the water will go down into the basement where the water reservoir is. So this is the final design for now, and I also made a sketch of how the rig will look in the laboratory. So you can see where the inlet and outlet pressure are supposed to be measured close to the pump, and the flow meter, and how the whole system is operating. So the flow will go up to the upper water reservoir, and then down to a pressure tank to stabilize the flow, through the flow meter, and through a regulating valve to regulate the flow rate in order to obtain different kinds of flow, and then down through the pump and down into the basement again. Yeah, so that's basically what I've done this semester, and further work will be to install the rig in the lab and conduct measurements and hopefully get some results. And the conclusion is that it's one step closer to get into space. So yeah, that's it.
Thank you.